Okay, so welcome to NVMe-oF CDS for Umbrella. Okay, so let's start with the first feature. It's about reducing the failover time. And to do it, we also need to change the way that we are sending beacons between the NVMe gateways and the Ceph NVMe-oF monitor. So just as a background, the current failover time is about 12 seconds. And we want to cut it short to be around 5 to 7 seconds. The reason why it takes 12 seconds right now is because we are waiting about 10 seconds to make sure that a gateway really disappeared before we start a failover. And right now also the beacon frequency is about 5 seconds, so it means that we miss around 2 beacons to start a failover. So what we do now is we are changing the way that we send beacons. We are making the beacons like only a much lighter and actually to include only the delta between the previous status. So the beacon itself will be much lighter, and that will allow us to send beacons more frequently. And then we will probably send beacons every 1 second or even less. And then we can say that we are starting the failover after missing 2 or 3 beacons, but this is going to be only 3 seconds and not wait 10 seconds as today. This of course will be configurable because it can work very good on a network which is very stable and not a network with hiccups. It might work, if you have hiccups in the network, then it might be that we are doing failovers, but we don't need to do failovers. We just think that the gateway disappeared. But for under the assumptions that the network is stable and resilient, we can probably go down to around 5 seconds for failover, or 5 to 7 seconds, and maybe even less. We need to do some testing, but so that's about this feature. Okay. The second one is talking about making the NVMe-oF gateways true active-active gateways. So right now, for every namespace in the gateway is served only by one of the NVMe-oF paths. But if we have multiple passes, we are not using most of them. In most cases, this is good enough and even more. But there are some cases in which people want to use all of the passes for different reasons. And that is, we call this active-active. And it means that the initiator can write to the gateway via multiple passes simultaneously. This is supported by the initiators, by every initiator actually, whether it's Linux or ES6. And in theory, this, we can just open it in the gateway very easily. We can say, okay, all the passes are active. And what the initiator will do is we'll just round robin across the passes and we'll send IOs. So in a perfect world, if we assume that we don't have any issues like IOs getting stuck in the gateway or in SPDK or in RBD or in OSD, in a perfect world, this is very easy. We can do it in less than 1 hour of work. But in storage, the challenge is to handle the bad situations, and in a bad situation, this can lead to data corruption. And that's the challenge in doing active-active, how to make sure that even if one of the IOs is stuck for whatever reason in the way, it will not cause data corruption. Because what could happen is that there will be a write ordering issue where, for example, write 1 to LBA 0 can be stuck on gateway 1, and then the subsequent write, like write 1 to LBA 0 with new data goes through gateway 2 and it succeeds very quickly. But then somehow write 1 that was stuck on gateway 0 is going through and it overwrites write 2. So we have this is the write ordering issue, and in this case, we have a data corruption. So we have a plan to handle this situation, but it requires quite a significant of development, and also testing it with every initiator and to make sure that it behaves the way that we expect it to behave. Like when is it doing the retry, and how long it takes it to do retries, and different things that we need to test. But that's the challenge in active-active. So that's one part of it. The other part of it is there is a new technical spec from NVMe community, which is called TP8028, Rapid Path Failover Recovery, which is trying to define an industry standard how to handle such cases. We cannot rely on that probably because the initiator still doesn't support it. This is also something we need to check. But in any case, we want to support it because probably at some point all of the initiators will work according to the rules of this spec, and we need to be prepared for that. Okay, so that's about active-active. From usability perspective, we have a few features. One is auto listeners. So currently, user needs to use the CLI to define listeners for every new subsystem. This is quite cumbersome and not required really, because we can do it automatically on his behalf. Well, first we can tell from the Ceph, we have enough information to tell what are the IPs of each node in Ceph, and that's one thing that we know. And the other thing that we know is that all of the subsystems will have more or less the same listeners. I would say 99% of the cases it will be exactly the same list of listeners for all the subsystems. So it's just adding a redundant and confusing work for the users, and we want to avoid it. So what we are going to do is to allow the user to define a network mask, or maybe a CIDR. We are still not sure about it. Where in the subsystem creation command, and then the gateway will automatically look for IP addresses on the node that match the network mask, and will automatically create listeners per each node on the subsystem. Of course, later on, we should be able to allow the user to change the network mask for each subsystem, and then to change the listeners accordingly. And we also need to support scale up or scale down scenarios. Like if you scale up, you have a new gateway, we need to add a new listener. If you scale down, we need to remove the listeners of the gateway that was removed. So there are some flows that are important to support for this feature. Okay, the next feature is the metadata pool. So currently we ask the users to create the pool that will store the gateway groups metadata, but this is not really, this is only confusing, and it's not something that we should ask the user to do. We should automatically do it when we deploy the gateway service, the first gateway service. And that's the idea behind this feature. And this might require making the NVMe-oF a new Ceph service, and that will make this task easier. So that's the explanation for this feature. Other than that, on the list, we have a bulk namespace creation. So when creating a namespace today, you can create only one namespace. And if you want to create multiple namespaces, you need to loop, like create some kind of a script or loop and call many times every time to create another namespace. But we can make it a bulk. Like if the user wants to create 100 namespaces with, I don't know, with the same size and on the same RBD pool, then why not allow him to create like 100 namespaces and that's it. It will save a lot of time going back and through between the CLI and the gateways, and it's also related to some dashboard enhancements that we are doing in allowing user to easily create namespaces, and so it's also simplifies the usability of the gateways. SOS reports. So we still don't have enough information in the SOS reports to analyze NVMe issues, field issues, or so we want to once again go over it and make sure that we collect all of the logs, all of the NVMe information that we need to analyze an issue when it happens. SPDK live statistics. So we want to provide some new CLI commands that will show in live the statistics about SPDK performance. So it will you will run the command and it will refresh every few seconds and will show the activity that was done in the last few seconds. And if SPDK is busy, the cores are busy, or and so on and so on. The next feature is a CSI driver. So we want to support, as a part of the CSI driver support of Ceph, we want to add also NVMe-oF CSI driver. That will allow cloud Kubernetes to also use NVMe-oF namespaces. Then the next item is to optimize the support for stretch clusters. So currently we do support stretch cluster, but it's not optimized, and it means that like if you have, for example, 4 gateways, 2 gateways on site A and 2 gateways on site B, on the same Ceph cluster, of course, and for example, site B fails. So right now it's not guaranteed. Or sorry, let's say that one of the gateways on site B dies. So we might wrongly do failover to a gateway in site A instead of to the other gateway on site B. And this might, it's not optimal, of course, for performance and for other reasons. So our failover logic should take into account the localization of the gateways. Encryption, this is a topic still being discussed, like what encryption modes we want to support in the gateway. Like we have, for the traffic between the initiator and the gateway, we have a TLS. encryption. Of course, this is not yet supported in ES6 initiators, but in Linux it will be supported soon. But then we need to decide how to encrypt the data from the gateway to RBD and then to OSDs. And then what we do is the data, once it's already in OSD, do we use OSD encryption or do we use RBD encryption? So this is something we are still discussing, and probably we'll have few options for the users, few configuration options. So that's about the encryption. Performance, we are working on a better integration between SPDK and RBD. We already have a code that knows to take the CRC that was calculated in SPDK and reuse it in RBD. It's not always possible, but in some scenarios, like in small IOs, for example, small write IOs, this is certainly possible. We still need to see if this is really improving the performance. In some cases, the expectation is that it will, because CRC calculations are consuming a lot of CPU. We still want to do it in the read flow as well, and that's one thing we want to do. We might need to develop more performance metrics in SPDK to be able, for example, to check how long it takes for the I/O between the initiator and the gateway, and like to be able to analyze the entire path between the initiator and until it goes to the SPDK and then to OSD and to RBD and so on. We might want to develop also load balancing based on actual load. So currently, our automatic load balancing is based on number of namespaces. But in some situations, this is really not solving the user issue, because you might have a single namespace or let's say 3 or 4 namespaces that are consuming most of the IOs, and they are sitting on just one of the gateways. So the fact that we did the load balancing according to number of namespaces is really not helping in this situation. So we might need to do it based on load, and this is like collecting statistics for a very long period of time, and only when we are sure that we can move a namespace between one gateway to the other gateway, then make this move. But this is like it will not be something that will happen very frequently. Like I said, it's something that maybe we need to take like 8 or even 12 hours, look at the load, see if we can identify any namespace that can gain from moving to another gateway, and then move it. So this is about load balancing. Interoperability. So hopefully we'll have Windows server supporting NVMe-oF very soon. We want to see that everything works there. We want to verify with Oracle Linux, and maybe even with other initiators. So that's the list that I currently have. And yeah, if anyone has any questions. Okay, no questions. Okay, so thank you. I guess that's it for me today.
Okay. Thank you for your time, Avi. And